Hi everyone. In this video, we'll be discussing the practice workbook answers for chapter 7, lesson 2. That's how to factor by using GCF. Now, definitely to know how to find the GCF of polynomials, you need to watch the previous video. I have left the link above. If you have by chance forgotten how to find the GCF, or if you have not watched, do go and watch that video, because this lesson will be completely dealt on GCF. So unless you know how to find the GCF, you will not be able to understand this lesson, right? So this is going to be explanation plus practice workbook answers discussion video. So here, before I start the answers for the practice workbook, these three things are the ones we are going to be looking throughout this lesson. That's we'll be factoring binomials, we'll be factoring trinomials, and of course we'll be factoring polynomials too, but you have only with 4 factors for this particular lesson, right? So you will be having 4 factors, so we'll be going through how to factorize these one by one. So binomials and trinomials, you know that you need to find the GCF for both of them and then factorize, whether you're factorizing a binomial or a trinomial. I hope you remember what are binomials and trinomials. Binomials are with 2 terms, okay, separated with a sign. Then trinomials, we have 3 terms, and for polynomials we have 4 terms or more. So here I would like to give you 2 tips here. So tip number 1 is to factor binomials and trinomials, we find the GCF and factorize them, right? So for binomials and trinomials, we just find the GCF of each, the terms, and then we factorize. But for polynomials, we have to definitely group them into binomials, and then we find the GCF and factorize them. So if you have a polynomial with 4 terms or more, you need to group them into 2 each, and then we will be factorizing them, right? So to start with, question number 1, 2, 3. Now always keep your work neat and clean. So let me just draw a line here, because we need to be finding the GCF of each of them. So let's start. So we have 8c squared plus 7c. We have to find the GCF of 8c squared and 7c. Now here I'm just doing it because it's the first question. So the GCF of 8c squared is going to be 2 multiplied by 2. That is the prime factorization for 8. Is going to be 2 multiplied by 2 multiplied by 2 multiplied by c multiplied by c, because it's a c squared. Similarly, we have 7c, which means there is no prime factorization for 7, as 7 is a prime number, and then we have a c. So we have only one pair of c common here, so that means the GCF of this is going to be c. So we write c, and then we are going to factorize it. So basically you're going to divide it with the c. 8c squared divided by c is going to give you an 8c, because c squared minus c is going to give you an 8c, and then plus 7c divided by 7 is only going to give you a 7. So this is the factorization for this particular question. Similarly, again, you will be finding the GCF of 3n cubed and 12n squared. So this is going to be 3, that's 1 multiplied 3 multiplied by n multiplied by n and n, so 3 n's, because 3 is a prime number, so there is no factorization for that. But 12 is not a prime number, so we have 2 multiplied by 2 multiplied by 3. Now if you are wondering how I'm getting this, it's simply this, but by now you need to learn how to do it mentally. So this is going to be n multiplied by n. So we have a pair of 3 common, so the GCF is going to be 3 multiplied by, and then we have 2 pairs of n's common, so that means it's going to be 3n squared. So we write the GCF out, that's 3n squared, and then open up the parenthesis. So if you would divide 3n cubed by a 3n squared, all what you are left with is an n. And then here 12 divided by 3 is going to give you a 4, and n squared divided by n squared is 1. So we do not usually write that, so that's going to be, in fact it's n squared minus n divided by n squared is 2 minus 2. So that's a 0, which means it's a 1. So it's n plus 4. So this is the factorization for question number 2. Again, similarly, we had to find the GCF of this 2. So the GCF of 15x to the power of 5 and 18x. Now 15 is not a prime number, so the prime factorization for 15 is 3, 5, and then x, 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 and x, 5 x's. For 18, it's going to be 2 multiplied by 3 multiplied by 3 multiplied by x. So for the GCF, we are finding the common factor. So we have a pair of 3 common and a pair of x common. So the GCF is 3x. So we write the GCF and we open up the parenthesis. So 15x to the power of 5 divided by 3x is going to give you, first 15 divided by 3 is 5, and x to the power of 5 divided by x is x to the power of 4, because 5 minus 1 is 4, and then minus 18x divided by 3x is just going to give me a 6 only, because x divided by x is 1 again, so that's nothing to do there. It's a 0 in fact, so it's a 1. So this is the prime factorization for 3x, and in parenthesis fx to the power of 4 minus 6. So this is how easy it is to factor the binomials. These are binomials because they have 2 terms each, right? So let's move on to trinomials. Now when you're factoring trinomials, definitely again you're going to be using GCF, right? So first let's find the GCF. So again, the GCF I will only do for one question here, because you all need to learn by now how to find the GCF mentally, right? So is that enough? Okay, let me make it a bit bigger, right? So let's find the GCF of 8s to the power of 4 and then 20t cube and 28. Okay, so this is going to be 2 multiplied by 2 multiplied by 2 multiplied by s 4 times, because s to the power of 4. So the prime factorization for 20 is going to be 2 multiplied by 2, that's a 4, and then multiplied by 5, because that's 2 2s are 4, 4 5s are 10, so all of them are prime numbers. And then 3 t's, sorry, 3 t's, because it's t cubed. Now for 28, it's going to be 2 multiplied by 2, that's a 4, and then 7, because 7, 2 is a prime number, 7 is also a prime number, and there are no variables. So there, the GCF for this is going to be, here we have a pair of 2 common, so 1, 2, and another pair of 2 common, so that's another 2, so the GCF is going to be 4. 2 multiplied 2 is going to be 4. So we write it out and then let's divide it. So negative 8 divided by 4 is going to give us a negative 2, and then there's nothing to do with the exponents, so we write it the same. Similarly here, 20 divided by 4 is 5, and then we have t cube, because we do not have any kind of variable here. Again, negative 28 divided by 4 is going to give you a negative 7. So once you find the GCF, all what you need to do is divide it. That's all. Similarly for question number 5. Now again, the GCF for 6n to the power of 6, 18n to the power of 4, and 24n. So the GCF is going to be, this is going to be 2 multiplied 3 and then n 6 times. So 6 n's, and here we have 2 multiplied by 3 multiplied by 3, that's n 4 times, and then here I have 2 multiplied by 2, that's, we are doing the prime factorization for 24, so I could say 2 multiplied by 2 multiplied by 2, so that's 2 2s are 4, 4 2s are 8, 8 3s will give me 24, and an n. So let's find the common pair here. So we have a 2 common, and then we have a pair of 3 3 3 common, so that's 2 multiplied by 3, that's a 6, and then we have a pair of n common, so the GCF is 6n. So write the GCF and then keep dividing them. Here you have 6 divided by 6 is 1, but we do not write that. So n to the power of 6 divided by n to the power of 1, we are going to get n to the power of 5, because 6 minus 1 is going to give us a 5. I hope you do remember that when you are dividing exponents, you have to subtract the exponential values. So you're basically, this for a quick review for those who might not understand what I'm doing, it's basically something like this. So all what you're going to do is 6 minus 1. So whenever you have to divide the exponents, you need to subtract the values. Right, so the next one is plus 18 divided by 3. 6 is going to give me a 3. And again, that's going to give me an n cube, because n to the power of 4 divided by n to the power of 1. That means 4 minus 1 is going to give you a 3. Here again, it's going to be only 4, because 24n divided by 6n is going to give me 4. So this is the factorization for question number 5. Right. Now here I'm not going to do the GCF because I have done already 5 questions on how to find the GCF. So the GCF, wait, why did I write 6? So the GCF for this is going to be 5 and m squared. Okay, so how did I find this? You can see that everywhere there is 5. So we usually remove the common terms. That's what we did here. The common numbers we remove. So 5 is common, so I took 5. And take the least exponential value, which is going to be like in every term. So that's n squared. So this is going to be negative 5 divided by negative 5 is going to give me a negative 1. But we usually do not write negative 1. So we ignore that one. But then m is going to be squared, because m to the power of 4 divided by n to the power of 2. 4 minus 2 is going to give you a 2. Then again, a negative 5 divided by 5 is going to give me a negative 1. Then again, it's just going to be a 1 m only, because m cubed divided by m squared. That's 3 minus 2 is 1, but we do not write the 1. Again here, 5m squared divided by 5m squared is going to give me a 1. So this is the factorization for question number 6. This is how easy it is to factor these polynomials. Right. Now for some problem solving. A ball is hit vertically into the air using a paddle at a speed of 32 feet per second. The expression negative 16t plus 32t gives the ball's height after t seconds. Factor this expression. So it's rather than a problem solving, it's a direct question. You just need to factorize this, that's all. So we are going to factorize negative 16t squared plus 32t. So the GCF for this 2 is going to be 16t. If you would ask me how you have to find, definitely if you cannot do it mentally, you have to follow the same method of factorizing here. But then you will definitely get the GCF as 16t. Okay, then again, here I will be left with a negative t plus 2. So this is the factorization for question number 7. See, it's easy. Once you find the GCF, it's easy for you to factorize it. Right, let's move to question number 8. The area of Margaret's laptop screen is 12x squared plus 3x. Factor this polynomial to find the expressions. Again, you need to just factor this. So let's factor it. 12x squared, it's a binomial. So 3x. So the GCF of this is going to be 3x. So that means 12 divided by 3 is going to give me a 4, and then x squared divided by x is going to give me an x plus 1, because 3x divided by 3x is 1. Similarly, like 6 divided by 6 is 1. So the same theory is applied here. 3x divided by 3x is going to be 1. So this is the factorization for question number 8. Okay, they said factor this polynomial to find the expressions for the dimension. Okay, they want you to find the length and the width. Now you know that area is comprised of length and the width, right? That too, the laptop screen is like a rectangle. So area is going to be length multiplied by width. So basically you could say the length is going to be 3x and the width is going to be 4x plus 1. So we do not need to write anything, we just need to write the dimensions are 3x and 4x plus 1. That's all, because they mentioned this dimension, so we have to work on it. So hopefully you have understood this. So whenever they ask for the dimensions, you just have to, you could pronounce this as dimension or dimension, it's totally up to you. Dimension is the British pronunciation and dimension is the American, so you can use any way you want, right? So the dimensions are going to be 3x and 4x plus 1, right? Let's move to the next one. Now factor each expression. You know, this is just like factoring the common factors. You could say that these two are common factors, and then so if both of them are common factors, we just take one of them, and then how about these two factors, we just group them together. So that's how you factor this expression. It's easy as eating a piece of cake. So if the two terms are equal, so factor them as 1, and then factor here there is nothing. So if there is nothing means it's always a 1. So which means 16b plus 1. Easy. So again, now we come to factoring the polynomials. Now you could see this is a polynomial because there are 4 terms. Now at the beginning of the lesson, I did mention if you are factoring polynomials, that's 4 or more terms, you need to group them into binomials and then factor them. So let's make them into binomials and then find the GCF of each of the binomials and then factor them. So here you need to find the GCF of 2x cubed plus 8x squared first. So the GCF of 2x cubed, now you could do this perfectly mentally, but I'm just doing it for one question. That's all. So this is going to be 2x x, and then this is going to be 2, 2, 2, x and x. So we are finding the common factors, which means it's going to be a pair of 2 and two pairs of x. Right here is a pair of 2 and then 2 x's, so which means the GCF is 2x square for this particular binomial. So I write 2x square here, okay? And how about the GCF of 3x and 12? So the GCF of 3x and 12, this is going to be 3 multiplied x, this is going to be 2 multiplied by 2 multiplied by 3. So which means the GCF is going to be 3. Right, so we have found the GCF of this binomial and this also. So let's factorize them. So 2x cubed divided by 2x squared is an x. Then here 8x squared divided by 2x squared, 8 divided by 2 is 4, x squared divided by x squared is going to give me 1. So I do not write it, I leave it like that. Now how about the GCF of 3x and 12? I found the GCF to be 3. So 3x divided by 3 is going to give me an x, and 12 divided by 3 is going to give me a 4. Now if you notice, both these are the same, which means we can rewrite this polynomial, we can write the factorization of this polynomial by saying x plus 4 and 2x squared plus 3. If you would multiply them using the FOIL method or using the vertical method, definitely your answer will be this particular polynomial. That's how you can check. Fine, so the same thing here, let's group them into binomials first, and then the GCF of these two are going to be n square, and the GCF of this is going to be 1 because there are no common terms here. Now if I would write 4n and 3, this is going to be 2 multiplied by 2 multiplied by n, and this is going to be 3. So there is no common term, which means the GCF is going to be 1. Never write the GCF to be 0 because there is nothing like GCF is 0. If there are no common factors, that means the GCF is 1. So here I write the GCF to be 1. Okay, let's factorize it. So 4n cubed divided by n squared is going to give me a 4n, and then plus 3n squared divided by n squared is going to give me a 4n plus 3. Then 4n divided by 1 is going to give me a 4, and 3 divided by 1 is going to give me a 3. So they both are the same terms, which means I could rewrite my polynomial factorization as n squared plus 1, 4n plus 3. If you have time during a quiz or an exam, if you want to check whether your factorization is correct, do multiply each of them by using the FOIL method or the vertical method of multiplication. That will definitely give you this particular question, polynomial, right? Again, here you need to group them. So let's group them together. So the GCF of 10d squared and 6d is going to be 2d. And this is going to be 7. So the GCF of 35d and 21 is going to be 7. So 10d squared divided by 2d squared is going to give me a 5d, and 6d divided by 2d is going to give me a negative 3 because there's negative sign. Similarly, 35d divided by 7 is going to give me a 5d again. Negative 21 divided by 7 is going to give me a negative 3. So both of them are the similar terms, which means I could write my factorization as 2d plus 7 and 5d minus 3. Once you get hold of finding the GCF, the remaining part becomes easy for you. So do a bit of back practice on finding the GCF, and the remaining will become easier. So again, I have grouped them into binomials. So the GCF of these two are going to be 3n squared, because the GCF of 12 and 15 is 3, and n cubed and n squared, the common terms are n squared. So again, the GCF of 8n and 10 is going to be just a 2. Here I'm going to divide, so 12 divided by 3 is going to give me a 4, n cubed divided by n squared is just going to give me an n. Again, negative 15 divided by 3 is going to give me a negative 5, n squared divided by n squared is 1, so I just do not write anything there. Again, 8 divided by a negative 2 is going to give me a 4. 8 divided by 2 is going to give me a 4, n plus, now here you are dividing a positive 10 with a negative 2. So it's going to be a negative 1 as well. Or what you could do is you could simply multiply, like negative into positive will definitely give you a negative 1. So negative 10 divided by 2 will give you a negative 5 if you would leave this out, else it's going to be the same. So the factorization for this is going to be 3n squared minus 2, 4n minus 5. Let's move on to the next question. Again, it's the same. Factorize the group them first and then factorize them. So the GCF of 5b to the power of 4 and negative 15b cubed is going to be 5b cubed. So if I would divide, I will get a b here and a 3 here, because 15 divided by 5 is 3. Then again, the GCF of 3 and b is going to be 1. Now, if you would notice here, it's plus and minus, so which means that's going to be a minus as well. So here I have 3 divided by 1 is going to be a 3, and negative b you're going to divide the whole thing. So that's what it means. All right, so this is going to be something like this. So now if you would notice, now b minus 3 and 3 minus b. Now there's a slight difference here. This is b minus 3 and this is 3 minus b. Now I could not say both of them are common because the same terms, because if I would rewrite this is going to be minus b plus 3. Right? So in such cases, when there's a slight difference in the signs, what do is you need to factor out a negative sign from here. Because when you factor out the negative 1 from here, what happens is that when you multiply them back, you're going to get the same factors. So because both of them are not the same terms, there's a slight difference in the in the signs. So what we are going to do is we are going to factor out the negative sign from here. So as a result, what happens is if you factor out a negative 1, this becomes a negative 1 as well, because that's a positive 1. Then when you factor out a negative 1, you're going to multiply both of them, so that's a negative 1. So we could rewrite this expression again as b minus 3, negative 1, and b minus 3. Always remember, if there's a slight difference here in the signs, remove negative 1 as a common factor and then rewrite the terms as the same. So here we have 5b cubed minus 1 and then b minus 3. That's all you've got to do. If you would notice, if I would multiply the negative 1 with the b, I'll get a negative b. And if I multiply negative 1 with a negative 3, I'll get a positive 3. So which means it's basically 3 minus b, which is the same one. So whenever you have some slight difference like that, always remove a negative as the common factor, and then you can factorize it the same way. Right, let's move to the next question. Here again, the GCF is going to be t squared. So that means it will leave me with a t minus 5. And here again, the GCF of this 2 are going to be a 2, which means a 5 minus t again. Right? So again, what does that mean? T minus 5 and 5 minus t are not the same. So what you're going to do, you need to remove a negative 1 as a common factor here. So when you remove a negative 1 as a common factor, what happens? This will become a negative 2, because negative 2, negative 1 will give you a negative, positive 2, negative 1 will give you a negative 2. And you could rewrite 5 minus t as t minus 5. Now, easy to factorize, t squared minus 2 and t minus 5. So this is going to be the factorization for question number 16. Only this, because of that slight difference in the sign, you need to factor out negative 1 and then rewrite it in the same term. You will get the same factors. So hopefully you have understood this lesson. It is an easy lesson, but as I always say, practice makes it perfect. So keep practicing. Till we meet again in the next video.